Hello and welcome to the second part of exponential properties. So we learned what happens if you multiply powers together. We learned what happens if you divide powers, where you subtract them. We learned how to get rid of parentheses by distributing, like we're going to be doing here again a little bit. So let's get into it. So this example here is actually very, very similar to what we did in the previous lesson, but we're going to expand on it. So we got a couple problems to talk about first, just to show, and then we're going to get more into it. So we saw in the previous video that if we were trying to get rid of the parentheses here, we would multiply the outside exponent by the inside exponents. And we saw that we can add our little ghost ones in here. And that would give us then 5 to the third power times by 4 to the third power. These two, because they have different bases, could not be multiplied together. We could not get like 20 to the third power. That's not allowed. So we could leave this like this. It says write your answers in exponential notation. So we want to leave them as exponents. Besides, these numbers would be fairly large. If we would actually multiply it out, we would get something probably too big that we wouldn't want to actually keep. If it was less than 100, maybe. Okay, again, we can multiply the outside exponent times by all the inside exponents, adding our little ghost 1 if we need to, giving us s to the, whoa, I almost put 8, 24th power times t to the 8th power. Again, those powers cannot be multiplied together because they have different bases. Okay, so this is old news. I'm going a little quickly here because we've already talked about this. If you don't know what the heck we're doing, maybe check the previous video on exponential properties. All right, so here's 2 for you to try, just as a refresher reminder. Pause the video, try these 2 right now, and when you're ready to continue, hit play. We'll go through them together. All right, letter C. We're going to distribute outside exponent to all the inside exponents, adding our ghost 1 anywhere we need to. This becomes 1.8 to the 8th power times by 9.4. That looks like a decimal, or it looks like a multiply. 9.4 to the 4th power. And that's it. We really can't do anything else. There's a possibility you could potentially multiply this since they're all numbers depending on the answers given on a multiple choice question, but for now, that's all we want. Letter D, let's see. I'm going to add my ghost ones first, so I need a ghost 1 on this 3. I need a ghost 1 on this P. Every single piece, each number, and each variable has its own exponent. And by the way, the number is called a coefficient. So multiply, 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 multiply gives us 3 to the 4th power, which I am going to multiply that out because that's going to be 81. M to the, whoa, not 5th. 5 times 4 is 20. N to the 12th, P to the 4th. And then again, when I multiply out this 3 to the 4th power, 3 caret 4 is 81. M to the 20th, N to the 12th, P to the 4th. This is what you'd want as your final answer. And we're done. Now, this is a bit different. We can actually simplify this, and there are times where we will need to. So what we're allowed to do here is, just like that distributive property, I can take the outside exponent and multiply by the inside exponents. And you're going, well, where are they? Well, each piece, each letter, and coefficient has its own exponent. So I can take the 4 times by that exponent and the 4 times by that exponent, giving me s to the 4th over t to the 4th. Okay, so it's still this distributing, but we're trying to show you that you can distribute even through a fraction, through everything on the top and everything on the bottom, everything gets distributed by that outside exponent. Here again, multiply by that exponent, multiply by that exponent. Add the exponents in, giving you 3 to the 3rd power over 8 to the 3rd power. And we could simplify the fraction. We could multiply out the top and get 27, multiply out the bottom and get 256, I think. No, 512. And then we could simplify the fraction, but we don't need to right now. Okay, I'm telling you that's an option, but we don't need to. So I want you to try letters G and H. Letter G should be fairly easy, just like the previous two. Letter H is a bit more of a challenge. I'm extending your brain a little bit. So pause the video and try these two now. When you're ready to continue, hit play, and we will go through it together. All right, so I would have taken this and written it as a fraction like this to start. I don't really like the division thing, this guy. And then I would add my ghost ones, boom, 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 and then I would distribute through, and I would get 4 to the 4th power over 9 to the 4th power. You could have left it with division as you had it and added in your ghost ones and distributed this way, and you would still get 4 to the 4th power divided by 9 to the 4th power, which these are equivalent, so that's okay, I suppose. Okay, expanding your brain a little bit. This one is a little bit more complicated. So if I start adding in my ghost ones, this 3 gets a ghost 1, that y gets a ghost 1. And now when we distribute, boom, 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 boom. Outside exponent multiplied by all inside exponents, top and bottom, everybody. So we now have 3 to the 4th power, y to the 4th power, over x to the 8th power. And I'm checking to see if there's anything I can simplify. X's and y's do not simplify. They have different bases. Same thing with that 3. Although that 3 to the 4th power, that number is relatively small, we can actually multiply it out, which we've done already today. That's 81. Y to the 4th over x to the 8th. This is what they would show on an answer key or on a test option, not this. They would multiply this 3 to the 4th out and get 81. So hopefully you got that. It wasn't too terribly bad. Okay, so now we've kind of expanded that property a little bit. Let's move on to the next. So the next 1 to 2 properties is we're going to look at the 0 exponent property and the negative exponent property. 0 exponent property is very easy. And what I challenge you to do is take any number on your calculator. So type in some number. It could be a decimal, it could be a fraction, it could be anything. I'm going to just do that, 2.4. And I want you to raise it to the power of 0. Do caret 0. Hit enter, and what'd you get? Everybody got an answer of 1. No matter what you put in, you always get 1. Because anything to the power of 0 is 1. And that's what the 0 exponent property tells us. Anything to the power of 0 is 1. Basically, we're saying there are 0 x's. There's no more x's left. But there's still something there. It's not going to be 0. It's going to be 1. Another way we can show this. If we had x to the 3rd power. Ooh, let me make the marker a little smaller. X to the 3rd power over x to the 3rd power. Now, any number divided by itself is 1. We can agree with that, right? X to the 3rd divided by x to the 3rd is 1. But we also learned that if you have 2 powers like this, to cancel them out, you would subtract top minus bottom, or you would cancel out top and bottom, and we would end up with x to the 3 minus 3 is x to the 0, which is 1. Okay, so we know this is 1. Using the properties we learned in the previous video, we know we could subtract these powers and we get x to the power of 0, but we know that's equal to 1. Okay, so that's kind of an explanation on why this works. A lot of folks just remember that anything to the power of 0 is 1. Now, how does that affect us in a larger problem like this? So for the most part, we can say, well, I know that this piece is going to equal 1. And when you take 1 times by anything, you just get that thing. It's kind of like that 1 disappears. If you take 1 times 5, you get 5. If you take 3x times 1, you get 3x. Well, when you multiply by 1, it's going to go away. So what it looks like happens whenever you're multiplying by 1 in a problem is it looks like that piece cancels out. It looks like it just vanishes. It's not actually vanishing. We're actually multiplying by 1, but 5 to the third power times by 1 is still just 5 to the third power. And then from there we continue on, and we can cancel top and bottom. I have an extra 5 left on the top. I have 1 extra 5 left on the top. And I don't really need my fraction bar, but I'm going to leave them in there in ghost format. More than likely you would just see to the answer of 5. I doubt they would show you 5 over 1. But I'm showing you that's, I mean, there's a ghost 1 there, there's a ghost over 1 there, but it's 5. We'd cancel out 2 of these, cancel out 2 of these. We'd have 1 5 left over in the numerator. All right. I would like you to simplify these two. These are both using the zero product property, or zero exponent property, and you might be confused because there's no 0 there yet. Go ahead and pause the video. Try these two on your own. When you're ready to continue, hit play, and we will go through them together. All right, so you probably saw when you combine the top, you add the exponents, you get 4 to the 9th power. On the bottom, you already have a 4 to the 9th power, which we talked about will equal 1. Anything divided by itself is 1. That's just a math property. But the way we learned to simplify this expression before is by that subtraction or the canceling. 4 to the 9 minus 9 is 4 to the power of 0, which we know equals 1. Letter D. This thing is to the power of 0. It equals 1. 1 times by 2.5 to the third power becomes just 2.5 to the third power. You multiply by 1 and you get that object back out. The times by 1 kind of goes away. That is the zero product property. So that one's very easy. Anything to the power of 0 is 1. Now, for the negative exponent property, this one is not as easy. And this one you're going to do a lot of throughout some of the more complicated problems. So the way the negative exponent property works, in our final answer, we are not allowed to have any negative exponents. That's one of the rules back up here. Answers should be expressed with only positive exponents. Okay, so how do we get rid of the negative exponent then? There's a few different ways. Here, in this problem, we could just combine our powers together. So, I mean, I've got two powers of the same base being multiplied together. I could add the exponents. So I could take 8 to the 3 plus negative 3, and I would get 8 to the power of 0, which equals 1. So we're allowed to do kind of the old operations, the things we know how to do already. But let me show you a different way. The way that you would normally get rid of a negative exponent in the middle of a problem, because sometimes this option is not always there. So the way you get rid of a negative exponent in the middle of a problem is you move that piece, the piece that's negative, has a negative exponent, you switch what side of the fraction he's on. So I'm saying you move it from the numerator to the denominator or vice versa. Here, we don't see a fraction, which means it's all on the top. I'm going to take this piece and I'm going to move it to the denominator. What's going to happen when I do that is, in the denominator, that 8 to the negative third power becomes 8 to the positive third power. When you switch an expression, or you move a piece from the top of the fraction to the bottom, it changes the sign of the exponent. It changed it from negative on the top to positive on the bottom. Now, if I could move this back up top, which I could theoretically do, it would change back to a negative 3. Negative 3 on the top, positive 3 down below. So here's this piece. I'm going to color code a little bit here to keep track of everything. This blue, well, he's going to stay up top. That was an ugly 3. Okay, so my 8 to the third, he stayed up top because he had a positive exponent already. I do not move him down. If I moved him downstairs, he would have a negative exponent. And now from here, we would just simplify the expression. That is 8 to the, well, I personally would cancel top and bottom, or you can look and go 8 to the third power divided by 8 to the third power. Man, that's just going to equal 1. Or 8 to the 3 minus 3, top minus bottom, is 8 to the power of 0, which equals 1. Okay, so there's a couple different ways, but I wanted to show you how you get rid of a negative exponent in the problem. You switch what side of the fraction it's on. Here's a pretty good example showing that. So I have a negative b and I have a negative 1. My c is positive. My c is not going to move. He is going to stay in the numerator. Now, my b to the negative second power, to make it a positive exponent, I'm going to move him down. And my a, to make it have a positive exponent, I'm going to move this piece up. And watch what we get. B to the positive second in the bottom changes the sign of the number when you switch what side of the fraction it's on. And I'm actually going to put the A piece first because typically you put the variables in alphabetical order. So A comes before C in the alphabet. And that A does have a ghost 1. I dropped it. I mean, a negative 1 would change to a positive 1, but we don't need to really write the 1. And I'm looking to see, can I do any more? These are all different variables, which means I cannot combine them, I cannot cancel them, I cannot do anything. We are done. I just got rid of my negative exponents. All right, here are 2 for you to try. Go ahead and pause the video, try these 2 on your own. When you're ready to continue, hit play, and we'll go through them together. Letter X, I'm going to get rid of my negative exponent. So this piece is negative. Oopsie, let's make him bigger. This piece is negative. I'm going to move it downstairs. So it's going to look like this. I have an x, that's this x. I have an x squared. But what's going to be on the top of my fraction now? There's got to be something there, right? You can't just have a fraction that looks like this. Well, it's a 1. It wouldn't be a 0. If you put a 0 there, then the whole thing just vanishes. It'd be 0 divided by anything, which is 0. And we don't want that. It's a 1. It's up there. And now in the denominator here, we can combine these two together. X squared times by x to the first power gives us 1 over x cubed. So when you multiply powers, you add the exponents. And that's what we get. Letter H. I'm going to get rid of this piece by moving it upstairs. I'm sorry, not get rid of it. I'm going to make the exponent positive by moving it upstairs. So I'm going to have an 8 and an 8 to the positive fourth power now. So I moved this piece up. It made its exponent go from a -4 to a +4. There is nothing in my denominator. It's a ghost 1. To simplify, I'm going to multiply my powers together, which means I'm going to add the exponents. And I don't really need the ghost over 1, but I'll put it there just so you can see that it is in the numerator, the top of the fraction. But the final answer you'd be looking for would just be 8 to the 5th power. They're not going to have the fraction in a final answer, not if you're simplifying. If you're simplifying, you get rid of the useless junk, like the ghost stuff. Hopefully you found those to be relatively easy. All right, so we've now learned all of the properties. The next step is putting all of those different properties together in ugly problems. So the problems are going to be a little complex. They're going to have lots of things to do. The trick here is keeping track of the different operations. When you multiply powers, you add the exponents. When you divide powers, you subtract them or cancel. When you have the parentheses, you distribute outside to inside. Anything to the power of 0 is 1. If you have any negative exponents, you need to make them positive before you're done, because answers should be expressed with only positive exponents. Okay? So let's look at letter A, and we're going to go through that process. So I'm looking at this. My first step, as always, is to get rid of the parentheses by distributing. This becomes 6 to the -8th power. 4 times by -2 is -8. Now I've got two things I could do from here. I could take this -8, the 6 to the -8th power, and I could move it to the denominator to make it have a positive exponent. Or I could, since these two powers are being multiplied together right now, I could just multiply them together by adding the exponents. We're going to end up with the same answer either way. So you have a little bit of choices here. I personally like to get rid of the negative exponent first. It's probably, no, it's the same number of steps. So I'm going to take this piece. I'm going to take this piece and move it to the denominator of my fraction. And it's going to look like this. 6 to the 3rd power over 6 to the now positive 8th power. And now I've got two powers with the same base. I'm going to cancel or subtract their exponents. Now, here's where I told you before that I don't really like the subtraction method of this, because if you would subtract top minus bottom, check this out. 6 to the top minus bottom gives you 6 to the -5th power. We got a negative exponent again. We're going to have to remove that thing to the denominator of the fraction, and it's more work. Check this out. My canceling method, though. I've got 3 6s up top and 8 6s on the bottom. If I start canceling, cancel, where do I have more 6s, top or bottom? Bottom. How many more 6s do I have on the bottom? I have 5 extras. So if I cancel these out, I'm doing a subtraction. See, 8 minus 3 is 5. I'm subtracting. But in my canceling method, I'm keeping track of where the extra 6's are going to go. All of these would cancel. I would have 5 extra 6's in the denominator. There they are. We need something in our numerator. It's a 1. That's the method that I would choose. Now, if you instead, so I'll change to blue for the other method, if you instead combine those together and you got 6 to the negative 5th power, that is negative 8 plus 3. When you multiply powers, you add the exponents. And then again, because this is a negative exponent, you're going to move it to the denominator of the fraction. You're going to get 6 to the 5th power over 1. They're both about the same amount of work. I talked longer on this problem, but they're both the same amount of work. Either way, same answer. Letter B. 2 different ways of doing this problem. Work hard or work smart. Work hard method is distribute to get rid of your exponent, or to get rid of your parentheses. You get 3 to the power of 0, m to the power of 0. I mean, I'm multiplying. We look and say, oh, anything to the power of 0 is 1, so that's 1 times by 1. Anything to the power of 0 is 1, and 1 times 1 is 1. That's the work hard method. And you might go, that wasn't that hard. You're right, it wasn't. The work smart method says, hey, all of this stuff is to the power of 0. So anything to the power of 0 is 1. The whole thing's to the power of 0, so the whole thing equals 1. That's it. One more for me and then one for you. So I'm going to cancel. I've got 2 powers with the same base. I can cancel 2 of these and 2 of those. I have no more 3's in the denominator, but I have 2 in the numerator. Oopsie. I'm going to make this a ghost over 1. You don't need it in your final answer. Your final answer would be just 3 over 2. I'm sorry, 3 to the 2nd power, which technically does equal 9. You might see 9 as an answer depending on the answer choices they provide. I think both are equivalent. Both are fine for me. Letter D for you to try. So why don't you go ahead and pause the video and try this problem right now on your own. When you're ready to continue, hit play, and we will go through it together. All right, so things to do. First, I would get rid of my parentheses by distributing. So I'm going to add in my little ghost 1's right there and there and there and there. Every single variable gets a ghost 1. Every single coefficient gets a ghost 1. So this becomes 2 to the 4th power m to the 4th power over 6 to the 4th power n to the 4th power. This could be done actually right now because you see how every single piece is different. I can't like combine m's and n's. I can't cancel anything. I can't really do anything else. The only thing that we could potentially do is simplify the number part. And I could do that by calculator. What is 2 to the 4th power over 6 to the 4th power? It's 1 over 81. So I could rewrite this whole thing as just, 1, I don't really need it, over 81 m to the 4th n to the 4th. We don't need the ghost over 1. Oopsie. So that, I probably would do that because, again, the numbers are relatively small. 81 is not too big. If it was like 3,252, we probably wouldn't multiply it out. We'd probably just leave it. But I didn't know what it was going to be. I just put in the calculator to check, and it's small enough that I think it would be okay. The numbers are less than 100. Okay, 2 more from me. All right. So, I'm looking here. Things that I see. Well, first off, I think this problem probably needs some parentheses here, just to make it clear that it's this divided by this. This would be on the numerator of the fraction. This would be in the denominator. I'm going to feel confident adding those parentheses in. I mean, I made the problem, but I think it could be made better like this. So the first thing I would do is I would rewrite this problem as a fraction. Oopsie. -2. There we go. Now, things that I see. I see this negative exponent should move up and make it a positive. And I see those numbers, 9/3, that is a fraction that we can simplify, and we will need to. So let's deal with the m's first. I would have an m and now an m to the positive second power. When I move him up, the exponent becomes positive. My 9/3, think about that as a fraction, 9/3. If you would simplify that fraction, what would you get? You get 3, or 3/1. 3/1. In fact, now that everything's in the numerator, this fraction bar is kind of worthless. And we simplify. M's can be combined together, need to be combined together. So I've got m to the first power here, m to the second power. So when I combine them together, we're going to get 3m to the third power. When you multiply powers together, you add the exponents. And that's done. Things I see. Parentheses is the first thing I see. I'm going to distribute here and here. That's going to give me 4 to the power of 0 over 4 to the power of 12 times by 4 to the power of 5. 4 to the power of 0 is just 1, the top part of that fraction, the numerator. So this would become 1 over 4 to the power of 12 times by 4 to the power of 5. And in case you don't know, that 4 to the power of 5 is technically a fraction. I mean, it's over 1. We can always add an over 1 to it if we don't see a fraction. So right now, those look like two separate fractions. And you might be thinking, well, how can I kind of group them together? And this comes back to your background knowledge on multiplying fractions that you learned in 6th grade, 7th grade, something. You learned that when you're multiplying fractions, you can multiply across the top, and then multiply across the bottom, and then simplify. So let's do that. 1 times 4 to the 5th power is 4 to the 5th power. 4 to the 12th power times 1 is 4 to the 12th power. And now when we simplify, I am not going to subtract because that's going to give me a negative exponent. If I do 4 to the top minus bottom, I'm going to get 4 to the -7th, and then I'm going to deal that negative. Instead, I'm going to go, out of these two, I have more 4s on the bottom. How many more 4s? 7 of them. So if I end up canceling top and bottom, all of these are going to cancel out. I'm going to get, well, I'm going to have 0 of them left. And we know anything to the power of 0 is 1. And if I canceled 5 of them on the bottom, I would have 7 left over. Answer. 2 for me, 2 for you. Go ahead and pause the video and try these two on your own. When you're ready to continue, or if you get stuck, hit play and we will go through it together. All right, let us see. Things that I see. I see a negative exponent that needs to move up. I see y's that can be canceled. Both of these things can be done in one step because each variable is kind of like its own little problem. So dealing with just the y's is okay, and then dealing with just the x's is okay. There's never a time where you're going to combine x's and y's together. So unless you have like parentheses, you can just treat each variable as their own little problem. So here's what we would have. I'm going to have a 5 here. I'm going to have an x to the third times by an x squared. So I moved this piece up. Now my y's, let's see. What would happen with these y's? Well, they would cancel, right? Top and bottom. If I cancel 2 of these and I cancel 2 of those, I have 2 extra y's left on top. Everything in my problem is in the numerator. So I'm actually going to get rid of the fraction bar. We don't need it. Last thing that can be done is these x's can be simplified. 2 powers multiplied together. You add their exponents. Oopsie, not the ghost tool. 5x to the 5th power, not 6. I'm not multiplying them. I'm adding the exponents. And that's done. Letter H, let's see. Parentheses first. Jum, ghost one. Gives me 6 squared, which is 36. K to the 6th power times 3k to the, let's take this piece and move it to the denominator. I want to get rid of that negative exponent. So I am going to actually make a fraction and move my k to the 8th power down here. So I did parentheses and moving negative exponent in one step. Okay, things I see. These can cancel. K to the 6th and k to the 8th can cancel. They are like terms, they can cancel out. I see this 3 and this 36, 6 to the 2nd power is 36. Those two can be combined together and multiplied because they're just plain old numbers. We're allowed to do that with just plain old numbers. So 6 squared, which is 36, times 3 is 108. That's not too bad. That's not too ugly. Now my k's, I got to figure out if they're going to be on the numerator or the denominator. Are there more k's up top or downstairs? Well, there's more k downstairs. How many more k's? 2. So when these guys end up canceling and canceling and canceling, I'm going to have 2 extra k's left in the denominator. That is our final answer. And if you didn't get that, start to figure out why. Where did your mistake happen? What did you do wrong? Did you accidentally take 2 times 6 and get 12? That's a common mistake. Did you combine this k to the 3rd power and this k to the negative 8th power before you got rid of the parentheses? I've seen that. I mean, there's places for mistakes here. And the way you learn is by fixing your mistakes. Okay? 1 for me and 1 for you. Let's see here. I've got parentheses. I'm going to distribute to get rid of, and here are my ghost ones. I think that's the only thing I can do in my first step. Okay, so I got 21 m to the 4th h cubed times by, I guess for something else I could have done. This whole thing is to the negative 1st power. I could have taken this whole thing and moved it downstairs. Whatever. because that's what I'm doing now. Now, this piece goes downstairs and this piece goes downstairs. They both have negative exponents, so to make them positive, I move them downstairs. And when they're downstairs, because the negative one changes to a positive one, I don't actually really need to keep the ones. I mean, you can. There's nothing wrong with it, but these are kind of ghost ones. I don't really need those ghost ones. They're not really helping me. But maybe you like them. Maybe they are helping you. All right, let's see here. Things I see. Let me change colors here so we don't get confused with old stuff and new stuff. Things I see. I see H's that can be simplified. I've got 3 on the top and 1 on the bottom. And I see these numbers here can be simplified. 21 over 3, think of it as a fraction. This is the fraction 21 thirds. Can you simplify those numbers? Yep. So what do we get? Well, 21 over 3 simplifies down to 7 over 1. So 7 over 1. M to the 4th. He's going to stay m to the 4th because he's not combining or canceling or anything with anybody. My h's, I've got 3 h's up top, 1 h down below. If I cancel or subtract, I'm going to have 2 extra h's left up top, which means I don't really need that fraction bar. So your answer would be just that piece, just 7 m to the 4th h squared. Letter J. I want you to pause the video and try this one on your own. When you're ready to continue, hit play, and we'll do it together. All right. So the first thing I would probably do is actually multiply. I would combine these 2 separate fractions into 1. It's just going to make, I think it'd make the math easier. You could have done this later on. You would have to have done it later on if you didn't do it now. So I'm going to have 3 times w to the 7th. I'm just throwing my multiply dots in there just to keep stuff separate for now. W to the 5th times 9 times w. All right, so when you multiply, it's 3 times w times another w to the 7th. 5w times 9 times w. Okay, so it's all now one big ugly fraction. All right, what do I see? I see I can combine those w's and those w's. So let's do that. 3w to the 8th, 2 powers being multiplied together. You add the exponents, and he is to the 1st power, just like this w on the bottom. Downstairs, I have a 9w to the 6th power. I rearranged. We usually have the numbers before any variables. Just like we normally have the variables in alphabetical order, we put our coefficients first. Things I see. We can simplify that fraction, 3 over 9, and we can simplify that expression. The fraction simplified is 1/3. The expression simplified is, well, I'm going to have 2 extra w's on top when I cancel. And I don't really need that 1. That is my final answer. Now you could have canceled w's, then multiplied, then combined, and canceling w's again. We should eventually get down to the same answer no matter what path you took to get there. Okay, got to get some practice under our belt to make sure we're good. So go ahead and pause the video, try these 2 on your own, and hit play when you're ready to go through them together. Letter K. Anything to the power of 0 equals 1, and essentially just kind of cancels out because it's going to become 1 times this junk. So I've got 3b to the 4th power. These have exponents of 1. I'm going to distribute my outside exponent to the inside exponents, giving me 3 to the 4th power, b to the 4th power, which we can rewrite as 81 b to the 4th. You could have, you possibly did, do this first. Boom, boom, boom. You could not go inside here, though, because he's inside parentheses, and you can't distribute through a second set of parentheses. This 1.4 is trapped inside by that 0. But you could have done this first, and then eventually you would work down to the same answer. Letter L, let's see. I would change this into a fraction first because I don't like the division symbol, that thing. You know, I'm going to do 2 steps at once. I'm going to change this into a fraction, but I'm also, just to save a little bit of time and space and brain power, I'm going to distribute as I'm changing this into a fraction. Boom, boom. So here's we go. 4 to the 2nd power, d to the 8th power, over. So here's my distribute. 4 to the 2nd power, d to the 8th power, over, and now this is going to be the piece in the denominator when I distribute. 2 to the 4th power, d to the 8th power. Things I see. The d's can cancel, and they're going to actually cancel out completely. D to the 8th power over d to the 8th power. They're all going to cancel. I'm going to have no more variable left in my problem. I see my numbers can cancel. So let's figure out what we got. D's are completely gone. So actually, I'm going to make the fraction bar a little smaller. Now, you could cancel this either in your head or with calculator. I mean, I know 4 to the 2nd power is 16. 2 to the 4th power is 2 times 2 is 4, times 2 is 8, times 2 is 16. Hey, this whole thing just equals 1. 4, let's clear this. Fraction 4 to the 2nd power, which I could have just hit the squared button, but 2 to the 4th power. Fraction. 4 squared, 2 to the 4th power. There we go. So I'm kind of using the calculator to simplify this. I already did it in my head once, but that equals 1. We saw that these guys cancel out. You would cancel 8 here and cancel 8 here. They're all gone. Or anything divided by itself is 1. Problem solving. We are almost done here. Arrange the exponential expressions in order from least to greatest. So we actually want to find the values of each of these and put them in order. So let's see. 5 to the 3rd power is 125. I know that in my brain. 5 to the negative 6th power. 5 caret negative 6 is going to be tiny. 0.1234, 64. This would simplify to 10 to the negative 4th power, which is tiny. 0.1231. That's just plain old 1, because this piece is the power of 0. Yeah, so the whole thing is the power of 0. It equals 1. And lastly, this gives me 81 over 64. I did this and this. I did an in-between step. The in-between step was 9 squared over 8 squared, and then there. And 81 divided by 64 is just a little bit bigger than 1. 1.26 something. All right. So now we can put them in order from least to greatest. The smallest number, well, first off, none of them are negative. If there was a negative number, I would have had that one first, but there's no negatives. So the smallest one is the one that is closest to 0, and that would be this piece. It has the most zeros in front, so it is the smallest number. Make my marker bigger now. So that's 5 squared to the negative third power. Followed by the next thing that's really close to 0, which is 5 times by 2 to the negative fourth. Followed by, 1 is the next smallest. 3 to the 8th to the 0. Followed by 9/8 squared, and then finally 5 to the third power, which was 125. So that is the order from least to greatest. Letter B, we want to match the exponential expression on the left with its equivalent expression on the right. All right, so I'm going to do a little bit of simplifying first. Ghost 1. That gives me 2 to the third power m to the 12th power. Now, 2 to the third power, I can simplify that. I probably should. 2 to the third power is 8. 2 to the third power is 8. So that one is now simplified. This cannot be simplified. Ooh, that one can. This can be simplified. That's what we got. We got 2 squared, m squared, m to the 8th power. 2 squared, m squared. So you got your ghost 1s. M to the 8th power. That can be simplified one step farther at 4, which is 2 squared is 4. M to the 10th power. This can simplify because of those two. And I get 4 over m to the 6th. I canceled 3 on the top and 3 on the bottom. These are all gone, and I have 6 left over in the denominator. So let's see what I can match up right now. So let's use black or red. Let's use red. All right. So, do I see any matches? I do. This matches up here. Those are the exact same expressions. This matches up here. Those are the exact same expressions. This matches up here, which means this last one should match up there, although they don't look the same because this one's not simplified. But I can do that quick. Distribute exponent. That's 2 to the third power m to the 9th over 2m to the 6th. This can simplify. That can simplify. We get 4. Oop, don't even need him. 4m to the third power. I did 3 minus 1 is 2. So I'm going to have 2 to the second power. Here's my in-between step. 2 to the second power. And then 9 minus 6 is 3. And then I did 2 squared in my head, which is 4. And we can see that it does indeed match up. Last problem? Yes, it is. Which exponential expression below would not have a value of 16 when h equals 4? Now, you could theoretically just throw every one of these into the calculator, putting in a 4 everywhere you see h. I think probably better than that, though, is to actually simplify. It just makes it easier for me. So this is h to the 8th over h to the 4th. I multiplied. And that simplifies down to h to the 4th. If I plug in 4 for h, does the thing equal 16? 4 to the 4th power. Does that equal 16? No. We found it right away. That would equal 256, which means all of these other guys should equal 16. Let's see. If I distribute and distribute, I'm going to get h to the 4th power over 2 And then when h is 4, I'm going to have 4 to the 4th power. Oopsie. That would be 2 to the 4th power. I was wondering why it wasn't working out. I made a boo-boo. So let's try this again. Now 4 to the 4th power over 2 to the 4th power equals, that one does equal 16. We're looking for which ones do not equal 16. Here, I would move this piece to the denominator, and I would distribute this in one step, giving me 2 squared, which is 4h squared over h, technically to the 1st power. These simplify, and that simplifies, giving me 4h. And we saw when h is 4, 4 times 4, equals 16. Remember, because h was 4 in the problem above, which does equal 16. And then lastly, the last problem. Distribute here and move this guy up top, giving us h to the 6 times by h squared. And that gives us h to the 8th. I'm wondering if I messed up on that first problem, because this does not seem, this one also is not going to have a value 16. So if I plug in 4 here, 4 to the 8th power is not 16. Did I mess up in the first one? No, I don't think so. I think just 2 of them don't have, 2 of them are not going to equal. Yeah. So that was a big number. So technically, I guess both of these don't have a value of 16 when h is 4. All right, summary. In your own words, describe how to turn a power with a negative exponent into a positive exponent. So how do you get rid of a negative exponent? Think about it. So to turn a negative exponent into a positive exponent, you just switch what side of the fraction it's on. Move it from the top to the bottom, or vice versa. Okay, this has been 2 lessons now on exponential properties. It takes a lot of practice to get good at them. So feel free to get some practice in and try homeworks and try problems online and see more problems and do them, okay? Thank you for watching this video, and until next time, toodles.